everyone, in this video we are going to discuss the trial paper for Negeri Sembilan. Alright, let's continue with number 6. So this is a diagram that's showing you the curve for a quadratic function. So point A and B are on the curve and A is the y-intercept of the curve. Okay, so A, the question is asking that state the reason why the inverse function does not exist. Okay, so we know that one of the representation way for for function is actually through graph. So for the x-axis is actually representing the domain. Then for the y-axis is actually representing the codomain, and the part where the images exist is actually called as the range. Okay, so we want to find out why the inverse function does not exist. So let's try to talk about a function first. So you might want to recall this. So for a function, right, for all of the object, you can eventually have one image only. Okay, so that's the definition for function. So which means that the relationship that we actually accept to be a function is one-to-one, definitely, right? Because in one-to-one, one object only have one image. So what is the other one that actually we recognize as function? So 1 to, you have like obviously many to many we can eliminate already, because it involved that one of the one of the object you have like many images, right? So we have 2 left, which is 1 to many and many to 1. So for 1 to many, which means that you have one object, then after that it might go to different images. So that's not what we want as a function. So which means the other one will be many to 1. Okay, so many to 1 in an idea that there can be like a lot of objects that go to the same image. But in another word, it actually means that one of the object only have one image. It's just that there are a lot of objects having the same image, so that's why. Okay, so we accept 1 to 1 and many to 1 as a function. So now we talk about the inverse function. So we know that inverse function is like the opposite operation, right? The reverse operation for the original function, right? So which means that when we talk about this is like the x and this is like the f of x. So from here to here is going to be like the f, then from here to here is going to be like the f inverse. So you can imagine if let's say I have a one-to-one function, then my reverse function is going to be a one-to-one as well. But then when you try to look at this, if I am having a many to one function, right? Yeah, because many to one is a function. So when we're trying to look at like many to one, so when you try to do the inverse, actually what happened? It eventually become a one to many, and one to many is not a function. So that's why some of the idea that you can remember over here is that for an inverse function to be exist, right, it must be a one-to-one function only. Okay, so other than that, actually is they will not have a inverse function. So for a function, one-to-one or many-to-one is considered a function. But then for an inverse function to exist, we only accept one-to-one, because only the reverse process for one-to-one gives us one-to-one, but the reverse process of many to one gives us one to many, which one to many is not a function. Okay, so that's the idea. Alright, so state the reason why the inverse function does not exist. So meaning that we need to prove that it's not one to one. So from this graph, you can realize that, let's take an easy example like the A and B given here. So you can see that they have the same y coordinate, right, which is the 6 here, and the B here, the x coordinate is 4, and here is 0. So what you can realize here is both 0 and 4 actually have the same image, which is 6. So in this case, we know that there are a lot of, it's not a lot, there are 2 objects that go to the same image. So that's why it's a many to one function. So it's because of it's a many to one function, so that's why there is no inverse function exists. Okay, so your answer, you can just leave it, is a many to one function. Alright, so I hope that you can understand the explanation. Alright, so let's move on to B. So the inverse function will exist in a specific domain. Okay, so go back to the idea that in the case where you want the inverse function to be exist, meaning that you must make the function to be a one-to-one relationship only. So how can we do that? So from this graph, right, you can see that if let's say I have like a parabola shape, then obviously I will have all the different objects to have the same image, because like for example, if I compare here to here, so you see they are sharing the same images as well. So although they are from the different objects, so the same thing when I move on, something like that. Okay, so how so what do I need to do so that I can set like a domain so that the inverse function will exist, meaning that how can I make this curve become a one-to-one function only? So which means that we can find the maximum point here. So what we try to do, we try to cut it into half. So you can realize that it's either that I take the first half, so which means that you can see for all the points here, right, for one object, I only have one image, because when you check like this, you see all of the points, they are having the different images, and they don't have like intersection when you try to draw like the horizontal line. Okay, or the other way is, instead of taking the first half, I'm taking the second half. So it's going to give me a one-to-one function as well. Okay, so we want to find out the midpoint here. So which means that what we try to do is the 0 and 4. Then after that, you plus them together and divide by 2. So this is how I get the midpoint here. Okay, so it's a 2 here. So which means that my domain, it can be x smaller or equal to 2, which is like the first half, or so the answer key actually only need you to state 1, but I'm just going to state 2. So just an idea for you, actually both can be accepted. So which means x greater or equal to 0 if let's say you want to take the second half. Yeah, so that's the idea. Okay, so that it can become a one-to-one and the inverse function will exist there. All right, okay, so that's the idea for number 6. All right, so let's move on. Okay, number 7. So the diagram here shows a graph function f of x equals to modulus 2 minus 3x, where given the domain here is from 0 to p. Yeah, so you can see that the x coordinate here is until p. All right, so find the value of p. Yeah, so which you can see that for this point, right? Yeah, for your a. Okay, for the point when x equals to p, the f of x is equals to 11. So we can use this information to help us to find p. Yeah, because it's given the coordinate here. So what we try to do next is by substitution. So since it's given that f of x is equal to modulus 2 minus 3x, okay, so x equals to p and f of x is 11. So we know that 11 will be equal to 2 minus 3p. Okay, so when you try to solve modulus, remember that modulus meaning that it will actually change the value of negative to be a positive value, right? So that's why when you want to solve it, then you will have to approach. So the first one is 2 minus 3p is equal to 11. Okay, which means that you have 11 and after modulus, you are still getting 11. Or in the other case, you have 2 minus 3p will be equals to negative 11. So actually you are getting negative 11, but because of the modulus, so that's why the negative is eliminated and you left with 11. So that's the idea. Okay, so we can continue from here. So we get 3p will be equal to negative 9, and after that p equal to negative 3. So in this case, then you have 3p will be equal to 13, and after that p equals to 13 over 3. So you can see that in the diagram above, right, actually we have only 1 point, so which means that it's either negative 3 or 13 over 3 and you need to pick one. So in this case, you can see that p is actually a positive value, right, because it's on the right hand side of the graph. So that's why p is equal to 13 over 3. All right, so that's the idea for number 8. So you get one answer here, then after that 1 mark here, so it's 2 marks for part A. So for here, then we know that the p is going to be 13 over 3. All right, so now we move on to B. So state the domain where the range is greater than 2. So in this case, we can see that the graph, yeah, if you can understand it from an idea for like the equation of the curve, right, equation of straight line, then you would be able to see that because f of x 2 minus 3x is actually a straight line, right, because mx plus c, and it's a linear equation. So the gradient is negative, which is -3. So you know that the original graph actually looked like this. Yeah. So you might ask like, how come I will take this part but not this part? So the idea is I know that the gradient is -3. So that's why for a gradient that's negative, is a negative, it's supposed to look like this. Then after that, the positive one look like this. So that's why the original graph is supposed to be like this, and because of the modulus, so it's reflected upwards. So which means that you don't have any negative f of x, right? So that's why it's reflected upwards. Yeah. So this is like the original graph. Then after that, mx plus c. So that's why this is the point that it should be 2 here. Okay. So that's the idea, like how you can get some idea for the function. But I mean, no worry lah. If let's say if you didn't get like the idea that actually this is 2, right? So what you can try to do is after you substitute, eventually you are getting to the same place. But the idea is when the range is greater than 2, so meaning that we are going to get, this is the part where the range is greater than 2. Because if this is 2, which means that anything above this is the range that we want, right? For the range that is greater than 2. So where is the domain that contributed a range of greater than 2? So you can see for the domain for 0 up to here, right, it's going to give you a number that is lesser than 2. So this is not the part that we want. So for greater than 0, which means that this is the line that we want. So what is the domain for this line? Then we have the n here, which is 13.3 already, right? So which means I need to find out this. Okay, so how do I find it? So it's the same thing. If I want to get greater than 2, which means that now my image is 2. So I'm going to substitute. So which means that 2 minus 3x will be equal to 2. Then I want to find the x. Okay, so by using the same idea, so 2 minus 3x will be equal to 2. And then the other one is 2 minus 3x will be equal to -2. Okay, so from here, then I can continue, like 3x will be equal to 0, then x is equal to 0. So yeah, it's okay. Let me finish first, then I try to explain it in a while. So 3x, then after that 4, so x equals to 4/3. Yeah. So from here, right, it actually proves that what you are doing is correct, because when the function is equals to 2, you have 2 points. So which is correct. When it's equals to 2, right, you have 2 points. One is at 0 here, then the other one is at here. So it's a number that lesser than 13/3 lah. So which is like an answer that makes sense and it's logical. So for this point, it's going to be 4/3. So it's not your answer here. Yeah, so don't just leave your answer over there. So you might just need to continue and then write down the domain here, which is like from this point up to this point. So that's why your domain, it should be an x that greater or equal to 4/3. Okay, I'm sorry, I think don't have the equal to, yeah, because you want greater than 2. So which means you cannot accept equals to 2 as well. So it should be x greater than 4/3, then after that lesser or equal to 13/3. Okay, so you might have a question that why do you need to add on this point? It's because of this function, yeah, it's only exists for x greater than 0 and smaller than p. So that's why when you are trying to write down the domain, right, greater than 0, which means it's actually on this sign. So anything that over the p is actually not the function that given here already. So that's why you should have a range that is greater than this point and smaller than this point. Okay, all right, so that's the idea for 7b. Okay, so the marking key will be given 1 mark over here, like 2 minus 3x equals to -2. Then you can get 1 mark. Yeah, because of x equals to 0 is the one that you should identify over here. So which means this is the value that you are finding. Then after that, your last answer, 1 mark. So it's a 2 marks. Okay, so let's move on to number 8. All right, number 8. The table here shows the distribution of score of a group of students in a max quiz competition. So find the maximum value for M if the mode score is 4. So now this is our mode score. So mode is supposed to be like the data with the highest frequency, right? So which means that if let's say the mode score is 4, meaning the highest frequency should be 12. So that's why if we want to find the maximum value for M, which means that for the score of 3, the maximum frequency for 3 is going to be 11, right? Because if let's say the frequency is 12, meaning that in this question, the mode score will be 3 and 4 already. So now if 4 is the only mode score, so which means the maximum frequency for 3 is going to be 11, right? So that's why M minus 2 will be equal to 11. So this is how you get M equal to 13. Okay, so from here, we solve A. Alright, so yeah, this is a pretty simple one. Then you can get 1 mark over here. So find the value of M if let's say the mean score is 3.5. So which means that now what happened here is we are looking at median. So median, which means like it's the center point of your data. So it's 3.5, which means that the center is actually at the middle of 3 and 4. Okay, so you can imagine if let's say when we try to write down all the score, right? So on the right hand side of your mode score, of the median score is going to be 12 plus 3. So which means you have 15 data on the right hand side. So since 3.5 is the median, so which means that I will also need to have 15 data on my left hand side. Okay, so that's why to find my M, which means that 5 plus 8 plus M minus 2 should be equals to 15 as well. So from this, then I will be able to get 3.5 as my median score. Okay, so from here, I'll be able to get M plus 11 equals to 15. So that's why M equals to 4. Okay, so as simple as that. So 1 mark for this. So it's a 2 marks questions. Alright, so move on to number 9. Okay, number 9. The diagram here shows the graph of function y equals to 9 over h to the power of x. Find the value of k. So this is a questions about linear law. Okay, so yeah, what do we need to do is from the function here, we need to change it to be a linear function, which is in a form of y equals to mx plus c. Then after that, we can get our answer. Okay, so the first step, let's try to change the function into a linear function first. So we have y equal to 9 over h power of x. Okay, so you can see here that your new y is actually log to the base of k then y. So which means that we'll need to add log at both sides. So log y equal to log k9 over h power x. Okay, so the next step is to split this out. So which means that because I want it to be in a form of y equals to mx plus c, right? So now we actually have our y already, which is like log base ky. Okay, so for here, then we need to split it out. So this is divide. So it will actually make it to be minus. Okay, so log k h power x. Alright, then the next step is we know that the power over here, we can bring it in front. So which I have log k power y equal to log k9 minus, so I'll bring the x in front. Okay, so I have log k h. So from here, you'll be able to see that my new x is actually x. So which means that this is the part which supposed to be like my y equals to mx plus c, my x term. So which means that this is eventually going to be my m. Okay, my gradient. So let us just try to rearrange the equation. So it will be equal to negative m. Okay, then after that, this is my x, then plus log k9. Alright, so now it's in the form of y equal to mx plus c. Okay, so each of the term represent each element here. Okay, So from the picture, then we are going to find out what is our k. So yeah, because we don't have any idea of like what is this point and we don't have like two coordinate, then of course we can't solve it in the way of the gradient, but we have our c, which is the y-intercept given here. So we know that the c will be equal to -2, and we know from the function here, our c is going to be log k 9. Okay, so which means that we need to solve this. So to solve it in an easier way, which what we can try to do is change it back to the index form. Okay, so we know that log k9 equals to -2. It actually means that k -2 equal to 9. All right, I hope that you are with me. Yeah, so basically it's like log ab equal to c is actually mean that a power c equals to b. So this is how you change from a logarithm form to a indices form. Okay, so for here, then I'll be able to continue. So let's change it to k square first. So since you have a negative, right? So which means when I bring it to the other, okay, let's try to do like this, then it'll be easier. So 1 over k square, okay, will be equal to 9. So which means k square will be equal to 1 over 9 and k will be equal to 1 over 3. All right, so in this case, you wouldn't be able to, yeah, so we know that actually from here, you are actually getting a positive and a negative lah. But how come we are only accepting the positive one is because of this is the base of a log, and a base of a log cannot be a negative number. So that's why k should be a positive number. So that's why k is equal to positive 1 over 3. All right. So for this question, the 3 marks will be given to the first one after you have rearranged everything. Then after that, you want to solve for this equation where you equate the y-intercept equals to -2, which is here. Then after that, your last answer, which will give you like 3 marks here. Okay, so let's move on to 10. Okay, number 10, given a quadratic function in the form of f of x equals to x minus px minus q, where q is greater than p. Okay, let us write down the information. Alright, so you need to express the range of the value of x in terms of p and q if let's say it's greater than 0 or is lesser than 0. Yeah, okay, so this is actually a quadratic inequality questions, which is yeah, if let's say I change it to number, then I think it will turn out to be a very easy question. So it's just that now they are trying to put it in a way that it's in a variable p and q, and then after that your q is greater than p. Okay, so yeah, it's actually a easy one. So you have f of x which is greater than 0, right, which tell you that x minus p and x minus q is greater than 0. So every time when we want to solve this quadratic equation, then we will, quadratic inequality, then we're kind of drawing this, right? So we have p and q. So normally you will need to write down the smaller value here and a bigger value here. And then after that, you are going to shade the point, shade the area for greater than 0. So now, because we don't have the exact number for p and q, but there's a clue that given in this question, which is q is greater than p. So which in another word, p is smaller than q. So that's why p should be at the left hand side, then after that q is at the right hand side. So it's greater than 0, so which means it's going to be the area here and the area here. Okay, so greater than 0 meaning like the f of x that you get is greater than 0. So we are treating like this is the x-axis, so greater than the x-axis, then greater than x-axis, which will give you f of x greater than 0. Okay, so for here, then I'll be able to get my answer, which is x, it should be lesser than p. Then after that, h should be greater than q. Okay, so the same thing goes to b. Yeah, so you have 1 mark for this. Then after that, for b, so it's going to be f of x smaller than 0. So we are going to do the exactly same thing. All right, so which means that we try to write in this quadratic inequality, then draw the same graph. So same thing, that p is smaller than q, so that's why p comes first than q. The only different thing is that it's smaller than 0. So that's why this is the part where we shade it. Okay, so you want to find an inequality here, which your x will be greater than p and then smaller than q. Okay, so your last answer, and 1 mark and 1 mark, so 2 marks. Alright, so that's the part for number 10.